All right, sixth period. This was an impromptu meeting that showed up today, so I'm here in the morning before school. I'm going to make you a quick video that I'd like you to watch. I'm going to go pretty quickly, so feel free to pause, rewind, work on example problems throughout the video so that you can understand this lesson, because this is the last lesson in this chapter, and we're going to cover two things. So this first page that you see here in your notes is what to do when we have to use U substitution when we're integrating. And then the next page, which we'll do in just a few minutes, is remember how so often when we U substitute we have something like this, u to the fourth, and then there's du over 3x, and the extra x terms just canceled out? Well, what if they don't? We have to learn that as well. And after today's lesson, you will know everything you need to know about how to do integration and the fundamental theorem of calculus. Okay? So let's start on this first page and let's get right at it. Fundamental theorem of calculus, remember you can find the area underneath the curve by integrating and then evaluating from the top interval and then subtracting whatever you get when you evaluate from the bottom interval. Okay? And we talked about how we need to integrate first, then we need to evaluate. Alright? The key point for when using fundamental theorem of calculus, when U substitution is necessary, is this. And now we're going to write it, and then I'll make it come to life down here with this example. Okay? You can do it one of two ways. You can integrate in terms of x and use the provided bounds. And I hope you know what I mean by bounds. I mean like this portion of the interval, or of the integral. Upper bound is b, lower bound is a. So we can either integrate in terms of x and use the provided bounds, or we can integrate in terms of u and create new suitable bounds. So if I had to define the lesson today in one sentence, it would be, when you're using U substitution, as long as you convert everything back to x, you can use these boundaries here that are given in the problem. But sometimes it's easier to leave things in terms of u, and if that's what we do, we cannot use these two boundaries. We have to change them. So I'm going to show you this same problem, but on the left side I'm going to solve it in terms of x and use the traditional boundaries, and then I'm going to show you how a lot of times it's easier to integrate if you leave it in terms of u. Okay? Again, pause as we go through this if you need to rewind, okay? And then I'll be back to answer questions later in the day. So, regular problem, fundamental theorem of calculus, we need to use u substitution. Here's our u. So we still off to the side, u equals x cubed plus 1. The derivative of that is 3x squared dx, and dx is du over 3x squared. Okay? And hey, good sign. 3x squared here, 2x squared there, the x squareds are going to cancel. So let me go ahead and say integral of, I'm going to go ahead and, well no, I'll write it. 2x squared, this is our new u, so it's going to be u to the 1/2 times du over 3x squared. Okay? The x squareds cancel. So we're left with the integral of 2/3 u to the 1/2. Okay? Notice I did not put the intervals here. I didn't put the 1 and the 2, the 1 and the 2. Here's why. In this problem, they're all x's. These numbers are in terms of x. So the minute I put a u in there, I can no longer put those numbers. I'm going to bring them back here in the last step once I've reconverted it back to x's. But notice how here there's a 1 and 2 and it's all x's. But when you start plugging in u's, you cannot put the boundaries because they don't make sense. Okay? But the reason we do this is because now let's integrate. Okay, u raised to the power will be 3/2 divided by 3/2, which is multiplied by a 2/3, and then there's already that other 2/3 there. So we're going to end up getting 4/9 u to the 3/2, and then I'm ready to say 4/9. I'm going to plug my u back in, x cubed plus 1 raised to the 3 halves. And now that, look, it's all back into x's, so now we can integrate from 1 to 2. Excuse me, we can evaluate from 1 to 2. And I'll just do that quickly. We'll plug a 2 in, that's 8 plus 1 is 9. 9 to the 3 halves is 27. So we're going to have 4/9 times 27, which is f of b, minus, plug a 1 in, that's going to be 1 plus, it's 2 to the 3 halves, which is the square root of 8. So we're going to have 4/9 times the square root of 8, and that's f of a. And I know I did that math quickly. It's because I did that problem yesterday. You can use your calculator if you need to. Or if it's a perfect square root like that and it's not ugly, you can leave it as a square root. Okay? And so now it's just simplification. 4/9 times 27, use your calculator, that ends up being 12, minus 4/9 times the square root of 8, which is just 4 on the square root of 8 over 9. And I would accept that as your final answer. Okay? So what did we just find? We just found the area underneath the curve, like always. Nothing new, it's just we haven't really done one with u substitution yet. So notice, nothing changed here. We start with this. We plug in u, we integrate, we change it back to x's, we evaluate. But you see how this is kind of a complicated evaluating section, okay? But what we can do, and this was when everything was with respect to x. Let me show you what you can do with respect to u on the right side. Everything stays the same until this step here. And watch what we can do. Okay? If we're at integrating 2/3 u to the 1/2, what we can do is we can integrate right here at this point, but we just have to find new numbers to go in this box and this box. We can't use 1 and 2 like the original problem gave us. So what we do is we try to use orange here to show you, we'll take these numbers and we will plug them in right here so that we can get u numbers instead of x numbers. Okay? So if I plug this 1 in to this equation, 1 cubed is 1 plus 1 is 2, that means that my new lower bound is 2. Because in terms of u it needs to be a 2. In terms of x's it needs to be a 1. You with me? So I need to take this upper boundary, which is a 2, I need to plug it in as well. 2 cubed is 8 plus 1 is 9. So my new upper boundary is 9. If you do this correctly, using 1 to 2 with x's is going to give you the same answer as using 2 to 9 with u's. Okay? It's just how it works. So let's integrate this right away. Let's take u to the 3 halves divided by 3 halves, which is 2/3 once again, times the 2/3 it's already there. Okay, so we got 4/9 u to the 3 halves, and we don't even have to put the x terms back in. We just go from 2 to 9 now. That's why we made it easier on ourselves. And once again, when you plug it in, you're going to have 4/9 times, look, it's going to be 9 to the 3 halves, which is 27 again. Minus, it's going to be 4/9 times 2 to the 3 halves, which is, once again, square root of 8. So I hope you see that it doesn't matter which way you do this, and you need to know both ways, because depending on what your professor in college, how he likes to do it, he or she could maybe solve it this way with respect to x, or she could solve it this way with respect to u. Okay? They both give you the same answer. Look, this matches up with that, but you need to be able to do it both ways. Okay? I don't have time to do another example because I have to keep this video under 20 minutes for YouTube. But if you need to rewind that and watch that again, I tried to go slow enough so that you can understand. Okay? The practice problems for this section are on page 4.4, I believe. Let me look in the book. One second. Nope, it's actually 4.5. So back to section 4.5. And we are doing problems 71 through 81 odd. So you can work on those now, probably while this lesson's fresh, then come back to this video for part 2. Okay? So pause now if you want to work on some of these practice problems. If you don't, and you're just a monster at calculus and you just want to keep going, then let's look at this section. What if the x's don't cross out? Okay. So far, everything we've done is canceled out. For example, look at this. U equals 3x squared minus 2. The derivative of u is 6x dx, and then dx equals du over 6x. You can already see this 6x and this 5x, they're going to cancel out at one point. Okay, but here's one where what if the x's don't cancel out? There's something small that we have to do, and it's going to test your algebra skills, but you guys can handle it. It'll remind you of when we were doing the complex derivative problems last unit. Okay, so here we go. Start everything the same. We have an integral, we have a quantity to a power, so I hope you know where to start. You come off to the side. U is 2x minus 1. Derivative of u is 2. Derivative of x is du over 2. And so right away I can see that this 2 is not going to cancel out with that 5x. If we were to set it up like normal, you guys would write this 5x times u to the 4th and then du over 2. And you can see this 2 and that 5x doesn't cancel each other out. So we're in trouble. So here's what we have to do. We have to make one more column over here. We have u du dx. Well, we need to isolate this x, because then we can substitute it in for this x, and we'll have everything in terms of u. Here's what I mean. U equals 2x minus 1. Let me get x by itself. So I'd add 1 over and then divide by 2, so it'd be u plus 1 over 2. So now we have not only u by itself, but x by itself. Okay? And we can then take this and insert it right there. And then everything will be in terms of u. For example, we'll be integrating 5 times u plus 1 over 2 times u to the 4th, and then du over 2 still. And this looks sloppy, but let me just give you something to work on, or to focus on. When you see a 5 on the outside and you see a 2 underneath here and a 2 underneath here, let's pull the coefficient out to the front. Okay, because when you do integration, for example this one, if I told you to integrate that, you guys would just ignore this 2. You would raise this to the 3rd, you would divide by 3, and then you'd bring the 2 back in. Same thing with this. Let's write it like this. Okay, let's have this 5 out here, and this divide by 2, this divide by 2, that would make it divide by 4. And then let's just have u plus 1 times u to the 4th. Okay, and we're going to ignore that 5/4 until the very end. Okay. Now here's where your just complex integration comes in. Remember what we would do when we'd have a product? There's no product rule, but we can just distribute. We have to get this down to individual terms. So we have 5/4 times u to the 4th is u to the 5th plus u to the 4th. Okay, now we're talking. Now we're ready to integrate. So when I integrate this, I get 5/4 times raised to the power, divide by the power, plus raised to the power, divide by the power. You with me? Integrated. Okay, now we're ready to distribute this 5/4 back through, and then we'll be done in just a second. So I'm going to have 5 over 24, which is where it gets kind of sloppy. 5 over 24 u to the 6th plus 5 over 20, which is going to be 1/4 u to the 5th plus c. And our final step is just let's re-plug in for u. We've got 5 over 24 times, what is u? You go back to your original problem, it's right there, 2x minus 1. 2x minus 1 to the 6th plus 1/4 times 2x minus 1 to the 5th plus c. So let me recap this. Okay? Everything the same to start. Everything the same to start. But the minute that you see that these x terms don't cancel out, then you know, hey, I need to go isolate x, and I need to replug that in and go from there. Okay? Honestly, if you're following very simply, I'll give you an extra kind of challenge step. See how this has 2x minus 1 to the 6th and this has 2x minus 1 to the 5th? You can technically pull out a GCF and simplify this a little bit like we did in the derivative unit. Since I'm not here, I'm not going to show it, but just so you know, I did show second period, and I want to challenge you for those who know how to pull out that GCF or remember to do it. Okay? One more example, and I have to keep this video under 20 minutes, so I will do, let me see if I want to do this one on the front. Yeah, let me try this one. Okay? Here we go. U, du, dx, as always. Okay? U is x plus 5. This is kind of fun. I hope you haven't fallen asleep already. Who's in sixth period? Riley's probably fast forwarded. He's probably not even listening to me. Bennett and Bond, who knows what they're doing. Hopefully Jackie can help you guys if you guys are lost. Jackie probably didn't even need to watch this video. Alright, let's keep going. du is 1. dx is du, because it's just 1. Okay? So automatically, there's no x terms here, there's an x squared there, so we're in trouble. So we have to go down here and isolate x. If you see that it won't cancel, isolate x, and x is u minus 5. How do I know that? I just subtracted the 5 over there. Okay? So here we go. We do everything like normal. We're integrating, but instead of x squared, we're going to plug in the u minus 5 into that slot. I'm using arrows to try to help you guys. Okay? So it's going to be u minus 5 squared times u to the 1/2 du. Why u to the 1/2? Because there's a square root. Nothing changes. All the rules apply. It's just we're doing this little extra piece. So then, we don't know how to do products, but u to the minus 5 squared is just going to be u squared minus 10u plus 25 times u to the 1/2. And now we can do a little distributive property, right? We have to get this down to individual terms. So we'll have u to the squared times u to the 1/2 is u to the 5/2 minus 10 u to the 3/2 plus 25 u to the 1/2. Okay? So then now it's time to integrate. We're ready. So raise to the power, divide by the power. Raise to the power, divide by, so 10 times 2/5 would be 20/5, which would be 4. I just did that math in my head. I hope you followed along with that. And then raise to the power, and then 25 times 2/3 is going to be 50/3. Oh, that's ugly. Okay, but this is what we ended up getting. So now we've completely integrated it, so we're just ready to re-plug in our u substitution, and we're done. So final answer will be 2/7 x plus 5 to the 7/2 minus 4 times x plus 5 to the 5/2 plus 50 over 3, which is a terrible fraction, x plus 5 to the 3/2 plus c. Once again, if you want to push yourself a little farther, notice this has an x plus 5, this does, and this does, so you can technically pull out the GCF of x plus 5 to the 3/2 and do a little simplification. Okay? But this lesson in a 2-sentence summary, this part 2 of the lesson is, if the x terms don't cancel out like they normally do, you have to add, I'll use a highlighter here, you have to add this section. If the x terms don't cancel out, you have to isolate x and then substitute that in so that everything is in terms of u. We have to get rid of our x's. Okay? Your homework for this section, so it's kind of a 2-part lesson today. It's also 4.5, but the numbers on the homework are 63 through 67. Okay? Work together on these. Ask questions to one another. Write down questions for me. And then we can look at this again on Friday. There is no Kia quiz this week. So once you finish this video and you've worked together and you've all finished the homework, because I know you can do this if you work together, then you will be done for the day. Okay? We do have a test next week after spring break. We have a test that block day. So study, work hard. Love you guys. And I just got this video under 20 minutes. Have a good one.